Welcome class to our video notes on Skill 6 from Unit 3. This video is going to walk through the process for simplifying complex fractions. And you might be thinking, well, aren't fractions already complex? And the answer is yes, but we're going to be looking at some that are even more complex than usual, okay? Also, the method that I'm going to teach you for simplifying them, I would say, is a little unorthodox. It's not the most common method you'll see used, but it's something that I've found to be a little more efficient and then leave less room for error in the end. It starts off with two sort of difficult steps, but if you do those correctly, the third and fourth steps will be much simpler than using other methods that are out there. Now, part of understanding my method is understanding what I mean by the overall numerator and denominator. What I mean by overall is looking at the entire complex expression rather than the smaller parts within it. So if you look down here at these different fractions, so like for number 1, for example, you see this fraction bar right here. And so what I mean by the overall fraction or the overall numerator would be like all of this. And then this x would be the overall denominator. But you might notice that inside the fraction, there's this fraction being subtracted by another fraction over that. There's like mini numerators, right? These two things, and mini denominators, those two things. But when I say overall numerator, I mean this whole part, okay? And then the overall fraction is this overall, the whole expression, basically. You can see that again in example 2. There's this fraction bar. So then this whole expression on top is what I consider to be the overall numerator. And then this x minus 2 would be the overall denominator, even though there's like these mini parts, right? Something over something minus something over something. There's like mini numerators, mini denominators, but overall numerator is all of that. Overall denominator is all of that. And then the third one you'll see is our very, very complex, most complex thing out there. So again, you've got this overall fraction bar in the middle, splitting these two up. This would be my overall numerator. That would be my overall denominator. And you can see within the expression, there's many numerators, many denominators, right? Many numerators, many denominators. But the overall numerator are these two fractions being added. This overall denominator is these two fractions being subtracted. And then this whole thing is what it's called the complex fraction, okay? So understanding that overallness as opposed to the smaller parts is important because that's what I focus on when I use my method. So basically what it will involve is you are going to have to look at the smaller denominators. You're going to have to look at all of the mini denominators and find the LCD of all of those. Okay, so it'll involve finding an LCD. But instead of creating a common denominator, so this is versus creating a common denominator, we are not going to do that, okay? When I added and subtracted fractions, I had to do that. I had no choice. But in this video, instead of creating, so this is versus, I'm not going to create, okay? Instead of creating a common denominator, I'm going to distribute the LCD to the overall numerator and denominator. And what that will do is it will actually, in one foul swoop, get rid of all of the mini fractions inside the larger fraction. It'll take it from being something like this over something, you know, like it'll take it from being like that all to just one thing over one thing in one foul swoop. That's what these two steps do. And then this last one at the end, you'll just have to combine some like terms and then simplify if possible. Okay, so if you do the first two steps correctly, then it gets you to just a much simpler expression that you basically just have to simplify. So let's try it with the first one, okay? With the first one, I can see that my overall fraction splits right here. All right, so when I'm looking at my denominators, I can see there's this one, and then if I look at x, I can think of it as x over 1, and so I can think of it as having a mini denominator of 1. Okay, when I'm looking at all my little fractions. The mini denominators are x plus 4, 4, and 1. So when I'm creating my LCD, I just need to find if there's any common factors, which there aren't, right? There's nothing in common between x plus 4 and 1. So since there's no common factors, then I just list each of these because these would all be considered remaining factors. So 4 times x plus 4 times 1. And you don't really need to write times 1 because it's not going to change the values. But I just kind of want to illustrate here. I'm just multiplying these three denominators together because they had no common factors. So when we multiply them together to create the lowest common denominator. Then what I'm going to do with that lowest common denominator is multiply it to the overall numerator, to this guy. And then also to the overall denominator, to that guy. Okay? So I think of this whole fraction, and I just multiply the LCD to the top and bottom of the overall fraction. And if you look at this here, what I'm really multiplying by is 1, right? When you take an expression, no matter how complicated it is, and divide it by the exact same thing, 4 over x plus 4, it divides to equal 1. The 4's would cancel, the x plus 4's would cancel, and this quantity equals 1. So when I take this whole entire complex expression and multiply it to 1, I'm not changing its value. I will change the way it looks. The way it ends up looking at the end will be different, but the value will be equivalent. So I'm creating an equivalent expression that is a much simpler version of this, right? That's why the instructions are telling us to simplify. Okay, but let's see how that plays out. So I'm going to rewrite the numerator, the overall numerator, as 1 over x plus 4 minus 1 over 4. And that is being multiplied to 4 times x plus 4. And then I'm going to take the denominator of x, and then that is also being multiplied to 4 times x plus 4. So I need to distribute in the numerator because the numerator is a difference. It's two things being subtracted. So I need to take this LCD and distribute it to both things. So it might help to think of this quantity as being over 1. So when I multiply it to fractions, I can be able to multiply straight across like we've been taught. So for this first fraction, and I'm not going to really simplify anything yet, I'm just going to put things where they need to go. So when I do 1 times 4 times x plus 4, that ends up in the numerator of the first mini fraction, and then that's all over x plus 4 times 1, which is just x plus 4. And then minus 1 times 4 times x plus 4 in the numerator of the second fraction, and then that's all over 4 times 1, which is 4. And then all of that is just over 4 times x plus 4. Okay, so this is where I'm at right now. You might be thinking, Ms. Lasner, this is not looking any simpler than it was before. But wait, watch this. The first fraction basically becomes a non-fraction, right? The denominator completely cancels out, and then same thing with the second fraction. So because I used a common denominator between the two, they both get reduced out when I multiply by that denominator. That's why we multiply by the common denominator, because it will get rid of every single denominator there is. So in the numerator, in the overall numerator, what I have left is 4 over 1, which is just 4, minus x plus 4 over 1, which is just x plus 4. The fractions in the numerator have just gone completely away. In the denominator, I have 4x times x plus 4, and I'm not going to distribute that because there's no need really. I will distribute this negative so that I can combine like terms, and I'll move that over here. So it ends up being 4 minus x minus 4 all over 4 times x plus 4. And then right here, you may notice, well, 4 minus 4 is 0, right? 4 minus 4 is 0. So those go away completely. And then I'm just left with negative x all over 4 times x plus 4. And then you may notice again, I now have a common factor of x divided by x. So that can divide to equal 1, right? So it just leaves a 1 in its place. And so this is my final answer. Negative 1 in the numerator divided by 4 times x plus 4 in the denominator. If you want, you can distribute that out, but you don't have to. And then you can see what x cannot be. So you look at all your different denominators from the beginning of the problem until now. So these here. So I can see from the denominator that has x plus 4 in it, and even from here, that x cannot be negative 4. And then also in the larger overall denominator, I can see this factor of x right here before it got canceled out was in the denominator. So that means I can't let x be 0 either, because that would make this whole denominator 0. So these are our excluded values for number 1. Moving on to number 2, again, you have this large complex fraction. Here's the overall fraction bar. So here's my overall numerator is 3 over x plus 4 minus 1 over 2. So I look at sort of those mini denominators there. And then this is my overall denominator, which is just like a whole expression. So you can kind of think of it as over 1, right? So that would be my little mini denominator in the overall denominator. And to determine my least common denominator, I just look at all of the mini denominators. And again, like the last example, they don't have anything in common. So I'm just going to multiply them to each other. So I get 2 times x plus 4 times 1. And again, you don't really need the times 1, but just for you to kind of see, I just multiplied them all together because they didn't have any common factors. And then I'm going to take that LCD and multiply it to the overall numerator and the overall denominator. Okay? So this is going to multiply to the top and also to the bottom. So if I write that out carefully, you can see it looks like this. So I've got 3 over x plus 4 minus 1 over 2, and that's being multiplied by 2 times x plus 4, all over the denominator of x minus 2, which is being multiplied by, again, by 2 times x plus 4. And just as another reminder, the reason why we multiply by the LCD over itself is because really what we're multiplying by is 1. If I multiply this overall expression by 1, I'm not changing its value at all. I'm just changing the look of it. So the eventual answer will be a much simpler version of this, and it will have the same value. So it'll be an equivalent, simpler expression. Now, when I do multiply all of this to the numerator, I have to understand I'm multiplying a whole expression to fractions. So it helps to put it over 1 and then distribute. And then when I distribute, I'm multiplying just straight across, multiplying each fraction straight across. So this first one would be 3 times 2 times x plus 4. And I don't do any distributing until I have to, right? Because oftentimes things cancel, and then I wait till after that to distribute. So I'm just keeping them like one product right now. In the second numerator, I have 1 times 2 times x plus 4, all over 1, basically. Oh, no, sorry, 2 times 1, which is 2. And then all of that is just over these 3 factors. But I'll put the 2 in front because we just most often do that. Put the single factor in front. And then what I notice is that all of the fractions that were originally in the numerator are going to go away because the x plus 4 is going to cancel here and the 2 is going to cancel there. And so in the numerator, I will just have 6, right? 3 times 2 is 6 over 1, so that's just 6, minus x plus 4 over 1. And I don't need to write over 1 because that won't change the value. So basically, I just end up with 6 minus x plus 4 in the numerator, all over these 3 factors, 2 times x minus 2 times x plus 4. And then I'll just distribute the negative in the numerator so that I can combine like terms. So I subtract x and 4, and all of that is over 2 times x minus 2 times x plus 4. And then when I subtract, since 6 and 4 are like terms, I can subtract them. 6 minus 4, I get 2. So I get negative x plus 2 in the numerator. All of that's being divided by 2 times x minus 2 times x plus 4. Now, think back to our first video, or maybe it was our second video on simplifying, when we talked about how if you factor negative 1 from a binomial, it changes the sign of each term, which if you have something like this, it can sort of reverse the order of subtraction. And the reason I want to do that here is because I notice in the denominator I have a factor of positive x minus 2, and I can turn this into that if I factor out a negative 1. So I'll take out a negative 1 from each of these, which will turn the negative x positive, and it'll turn the positive to negative, right? It changes the signs of each, and as a result, it reverses the order of subtraction. And so then I notice I have a common factor now between my numerator and my denominator. The common factor is x minus 2, so then that can cancel out at the end. And then I'm just left with negative 1 on the numerator, and then 2 times x plus 4 in the denominator. And so that's my final answer, right? Much simpler version than what it was before, right? It's much simpler than that. Now, for the excluded values, I'm just not going to let x be negative 4, because that would make that 0. And if I look at the original denominator over here, I can't let x be 2, right? Because that would have made that denominator 0. And I think that it covers everything. So those are my excluded values. Now, number 3 is very complex. This one is going to be difficult it's just going to be difficult. It's got actually 5 different fractions altogether. 1, 2, 3, 4, and then 5 is the overall one. And each of the denominators are different. So it's just going to be messy. There's no way around it. But we're going to use the same process. We're going to look at all of my little mini denominators, this guy, and then that guy, and then that guy, and then that guy. All my mini denominators, and between them, I'm going to find a least, emphasis on the least common denominator. So my least common denominator is you look at all the different factors, right? And you only list the common factor once. So I have a common factor of x plus 1. I only need that one time. And then I list my remaining factors of x and x minus 1. So this is the common factor. You only list it once. And then these are the remaining factors. Each one of those has to be listed as well. And so that's my LCD. So what I'm going to do is take that entire LCD and multiply it to the overall numerator and denominator. I am going to write it like this instead. I like to put the single factor in front. So that's my LCD. So this time it's 3 things. So that's, complicated. And then I'm going to distribute that to the top and also to the bottom. So that's going to be a lot of work. So let's go ahead and do that. So for the numerator, I have x minus 2 all over x plus 2 all over x plus 1. And that's being multiplied by x times x plus 1 times x minus 1 all over 1. That's my overall numerator. And then in my overall denominator, I have 3 times x minus 1 minus 1 over x plus 1. And that's all being multiplied by the same exact thing, right? So you multiply the same thing over itself. This quantity here just equals 1, which will give me an equivalent but simpler expression than what I currently have. And then my job is to distribute all of this to both terms in the overall numerator and in the overall denominator. So then I have this. So for the numerator of the first fraction in the numerator, I have x minus 2 times x plus 1 times x minus 1 all over x plus 2 times x plus 1 times x minus 1 all over x plus 1. That's my overall numerator. All of that is divided by 3 times x plus 1 times x minus 1 all over x minus 1 plus 1 times x plus 1 times x minus 1 all over x plus 1. So it looks crazy right now. It looks so crazy. But all of these 4 fractions are all about to go away just like that. So in the first fraction, the x cancels. In the second fraction, the x plus 1 cancels. In the first fraction in the denominator, the x minus 1 cancels. And in the second fraction in the denominator, the x plus 1s cancel. So all of my mini fractions just all went away. In the numerator, I will have to do a lot of FOILing, but let's get to that in a second. So I have x minus 2 times x plus 1 times x minus 1 plus 2x times x minus 1. That's my numerator. All the denominators are gone. And then in the denominator, I have 3x times x plus 1 from here, and then plus x times x minus 1 from there, and then no more other denominators. So it was very crazy for like a second, and now it got a lot simpler. Okay, so I will FOIL. I'll do these first because I just noticed right away that makes a difference of squares when you FOIL them. So the nice thing about that is it just gives you a 2-term, it gives you a binomial basically. So let me show you that like right here. If you do x plus 1 times x minus 1 and you FOIL it, the middle terms will cancel out. X times x will give you x squared. X times negative 1 gives you negative x. 1 times x gives you 1x, and then 1 times negative 1 gives you minus 1. And then a nice feature is that these middle terms cancel out. So then I'm left with just 2 terms, right? X squared minus 1. So I can replace this with x squared minus 1, and that'll make it a little easier when I have to still FOIL that to x minus 2. So let me write it like that. So x minus 2 is going to eventually get FOILed to x squared minus 1. And then I'll go ahead and distribute the 2x. So I get 2x squared minus 2x. And then all of that is over. I'll distribute the 3x. So I get 3x squared plus 3x. and then I'll distribute the x, so I get plus x squared minus x. And then I will need to FOIL this right here, and then once I do that, I can just go ahead and combine like terms. So let's see, I'll get x times x squared is x cubed, x times negative 1 is negative x, negative 2x squared is negative, or negative 2, yeah, it's negative 2x squared, negative 2 times negative 1 is plus 2. So this turned into those 4 terms, and then I still have plus 2x squared minus 2x. And then all of that is divided by, and I can start combining like terms on the bottom because they're already FOILed out. So I can add 3x squared and x squared, and then I can also add positive 3x with negative x. So on the denominator, I have 4x squared plus 2x. And then in the numerator, I can start adding things because I notice I have, well, I can't add anything to x cubed, so that won't be able to add, but the negative 1x can add with negative 2x. And the negative 2x squared can add to positive 2x squared, and actually since those are equal but opposite signs, they'll just go ahead and add to 0, so they go away. So then in the numerator, I'm left with x cubed minus 3x plus 2, and then in the denominator, I'm left with 4x squared plus 2x. Actually, hold on. I'm noticing here that I made a mistake earlier in the problem right here. I realized that was actually originally a subtraction right here. It was a minus, and then somehow right there I turned it into a plus. So I need to fix my mistake. So that should be a minus. And then over here, it should be a minus. So when I distribute right here, I have to distribute a negative x. I have to distribute a negative x. So actually, that changes what the signs should be in this step. This should be a negative x squared, because negative x times x is negative x squared. And then this should be plus x, because negative x times negative 1 would be positive. So when I'm combining like terms, actually these numbers should be switched. It should be 2x squared and plus 4x because it'd be 3 minus 1. 3 minus 1 is 2, and then 3 plus 1 would be 4. So that changes my final answer a little bit. It should be 2x squared plus 4x. Okay, so caught that mistake. And then this is our final answer here. If you want to factor the denominator, you can, but you don't have to because the numerator won't factor, so I know nothing's going to cancel. But just so you could see, the other option would be to take out a 2x on the bottom, and then you have x plus 2. So this is another way of writing that, but not necessary. And then for my excluded values, I notice that x can't be 0 because of this factor. It can't be negative 2 because of that factor. But then if you go back to the original problem and look at all of the original denominators, you can see it can't be negative 1 or positive 1 either. So 4 things that x can't be for this problem. So sorry about that mistake. Hopefully you were able to follow through the corrections. And these are our final correct answers here, and these are the excluded values. And I'll see you in class for some practice.